Hi everyone and welcome back to Newegg TV. My name is Paul and today, back by a special request, we have JJ from ASUS, the Conquistador. He is back, he's clean shaven this time, but we are here to talk a little bit more about the fantastic new product launch. Actually two products, they're distinct but they work together, that have just launched. First off, we have this guy right here. This is an Intel Sandy Bridge E processor. That's the enthusiast level processor. There's a new socket for this processor, the 2011 socket, and just by coincidence we have a bunch of socket 2011 motherboards right here. And paired with this is the X79 platform, which is the chipset that's integrated into all of these motherboards here, which has, let's put it mildly, a lot of new features and a lot of new capabilities that go hand in hand with the Sandy Bridge E processor.
That would definitely be the case. I mean, when we're talking about Sandy Bridge E, we're really speaking to the true enthusiast segment. Where Socket 1155 is an awesome platform and it really can do almost anything you ask of it. X79 and Sandy Bridge E kind of take it to the next level in terms of both the performance, the versatility, and the overall functionality of what the platform is affording you. So this time around, really what we're doing is we're extending the architecture that was introduced with the Sandy Bridge processors. So those were your processors like the 2600K, 2500K, and now that incorporating that onto the more advanced core count and more advanced cache that's offered on Sandy Bridge E. So for kind of, it's like an amalgamation of the previous generation Bloomfield or Gulftown parts, but then incorporating all the advancements that you have architecturally from Sandy Bridge. So what you're going to be looking at initially here at the launch is going to be two parts, an Extreme Edition part and then a K part. Both of them are going to be essentially offering unlocked multiplier controls as well as some more advanced overclocking options, which we'll dive into a little bit later in maybe our overclocking segment. But what you're talking about in terms of the performance, one comes into really high multi-threaded performance because we've got 6 cores and then via hyper-threading we have 12 threads available to us. You then also extend the cache. In terms of L3, you're going up to 15 megabytes or 12 megabytes depending on the CPU. And then from that, then the the clock per clock increases in performance. Really just talking about a huge increase, especially for users that were maybe on the original X58 platform and maybe a Bloomfield 920. You could be talking about increases of performance over 100%. Depending on the application or the workloads that you're working with. So pretty impressive.
So for the extreme users out there, the enthusiasts who are right now maybe still running X58 because that was the previous enthusiast platform, maybe going with a Gulftown 980X or 990X right now, this is really the next step as far as those who are looking to stay at the bleeding edge of computing.
Yeah.
Because again, both of the K part that we have right here, as well as the Extreme Edition part, both have 6 cores, 12 threads, as well as the higher clock speeds that you're talking about.
That's correct, yeah. And in terms of overclocking performance, we're also extending that in comparison to the Bloomfield generation of parts, where in most situations, generally you were talking about on air cooling a limitation of about, say about 4 to maybe 4.2 gigahertz if you had a really good quality air cooling setup. Gulftown, of course, that extended it a bit more because of the transition down to 32 nanometer, but due in part to the Sandy Bridge architecture and also the drop down to 32 nanometer and some optimizations that Intel have made, we're talking that most of the CPUs on the market under air configurations are going to be somewhere between about 4.4 to 4.6. A little bit better CPUs are going to be exceeding the 4.6 to 4.8 marker, and really exemplary CPUs will be hitting even 5 gigahertz, maybe even more than that, under the best cooled environments. So this is really an enthusiast platform. We talk about 4.8 gigahertz plus on air, 12 threads, and then high density memory configurations, quad channel support, more PCIe lanes. It gets really cool, really impressive in terms of what you can do with it.
And now before we move on to the motherboards and X79, for those of us out there who might be currently running the Sandy Bridge platform, not Sandy Bridge E, the 1155, just to clarify, because there have been some questions out there since this is just now launching, for those who are using the performance mode, 1155, this is really faster, just all around. It's faster, it's better, it's no matter what you're doing with this, chances are you're not going to be able to achieve that same level of performance with the 1155 Sandy Bridge.
Yeah, 100%. I mean, you get some key advantages right on the offset. So from the beginning, clock per clock performance is generally identical, if not exceeding performance for the same thread load, right? As soon as you throw anything that can support more threads, even in some of the newer games that are coming to the market, such as Battlefield 3 that's already on the market, Rage, and other game titles, as well as also workload titles themselves that can take advantage of more cores, you're going to exponentially start increasing the performance. So that's one key criteria that we know that we're getting the bump. Two, the quad channel support, as well as the higher density memory, is going to allow us to do some really interesting things that are just not achievable, both from a cost per density bracket on 1155, as well as the bandwidth that's available to us on the 2011 Sandy Bridge E-socket X79 platform. You also have more PCIe lanes. So just like under X58, where those more PCIe lanes gave us more flexibility to run either native three-way support or have more active devices. It's not something that a lot of people always took in consideration, but on 1155 you ran into sometimes limitations on dual GPU configurations. Maybe you're running USB 3, you're running back panel USB 3, eSATA, maybe other devices. Running those all actively generally required maybe one controller to be shut off, as opposed to another controller being enabled. With the more PCIe lanes that we have available on X79 and from the CPU, it gives us more flexibility in terms of keeping more devices active at one time. So this once again also helps to reinforce that this is really an enthusiast-oriented chipset. So that, as well as other special enhancements to the instruction sets and some other special sauce that's been incorporated in terms of the CPU, really help to extend this out in terms of really being the fastest product you can buy on the market right now.
And with Sandy Bridge, you get, I believe it was 40 PCI Express lanes as compared to the 24 that you got with Sandy Bridge.
Correct. In terms of the platform, which you're going to be looking at, well, on Sandy Bridge 1155, directly from the CPU, you only have 16. Then the rest are comprised of different multiplexing chips, whether you have the PCH and other variables that come into play. So definitely on die, the PCIe lane count is greater on Sandy Bridge E than it is on normal Sandy Bridge part, and that's once again to reinforce that this is the enthusiast chipset market.
Okay, let's talk a little bit more specifically about the motherboards that we've brought along here. These all feature the X79 chipset, and since we've already mentioned it, let's start out and talk about the quad channel memory. And I've noticed that for the ASUS implementations here, you guys have gone with a full 8 DIMM slots, so you actually get not just 2 and 2, but 4 and 4 for the crazy amount of memory that you can have installed here. Even if you're using 4 gig DIMMs, you can get 32 gigs, and now 8 gig DIMMs are becoming available, so you can actually go up to 64, which is, and you were mentioning that there are a lot of other applications besides just having that greater amount of memory available, but some other fancy things that you can do with that to take advantage of that memory capacity.
Definitely. I mean, a big focus for us at every chipset launch is to have key points of design consistency, so that regardless of the user and which motherboard they're considering, they're going to have key points on every single board that they know are going to be present. So one of them definitely that on a very low level was going 8 DIMM pretty much across all the boards that you see here. First and foremost, one is because this platform supports quad channel. Two is that we want to give users the most flexibility at density and maximum achievable memory. As we know right now, DRAM's pretty inexpensive, and you've got some really great choices in terms of quality, performance, and frequency. So, for example, like you noted here, we've got this Corsair Vengeance DDR3 1600 kit, and we've got 16 gigabytes here, another 16 gigabytes here. Now that gives us 32 gigabytes. Now this is awesome. We've got the quad channel support, got this higher bandwidth, but what are we going to do with it? The great thing that we can now do with some new advanced software that's available, as well as having this density of memory, is we can do some really interesting configurations that we'll show in some of the other videos. But imagine having 8 gigabytes allocated to solely your RAM, your operating system for your, RAM for your operating system. Then we have the other set of memory that's going to be allocated maybe as a RAM cache. So a RAM cache would serve kind of the same functionality as an SSD cache, but instead of caching through an SSD, you're caching directly through RAM. So this will accelerate all key applications and executables. And then from there, we could have this whole bank of memory here, so this other 16 gigabytes, dedicated as a RAM disk volume. So for either key large applications, maybe like Adobe Photoshop, Microsoft Office, or maybe even like a game. Battlefield 3 is only 11 gigabytes, 12 gigabytes. You could load the whole thing and actively run it solely from system memory. So this once again kind of enforces part of the reason why we wanted to go with an 8 DIMM configuration, give you the most flexibility that you could have. Even if maybe you initially only start off with 4 DIMMs, it's very easy to go ahead and upgrade to another 4 DIMMs and give you a higher density of memory that you can start playing around with. So some very cool things that you can do with 8 DIMM configurations.
Now, we've been fortunate enough here to be able to work with a lot of higher-end SSDs. In your experience working with, say, a RAM disk setup like you're talking about, what's the comparison there, even with, say, a Gen 3 SSD?
Yeah, it's exponential. I mean, we'll definitely dive into this deeper, and you can see the actual performance numbers. But when you talk about that, the peak SATA 3 SSDs on the market are achieving maybe about 550 megabytes, whether it's on the read or the write. You could talk about on a RAM disk configuration, you could be exceeding 7 gigabytes worth of active throughput.
That's a pretty huge jump.
Yeah, so the benefit of being able to run your applications directly from that becomes really, really, really cool. And like I said, really achievable easily on the X79 platform.
Okay, and we're going to go into more of that. We'll have a follow-up video where we do a bit more testing and benchmarking with that. But let's move on to the chipset itself, X79. As compared to, say, X58, what sort of benefits do you get if you're an enthusiast-level user moving up from the old enthusiast platform?
And that's a great actually place to start off from, because so X58, for the guys that are running 920, 930s, maybe only 6 gigabytes of RAM, those initial things, they're getting a lot of upgrades. Not only are getting the clock for clock increase, better overclocking support, quad channel, 8 DIMM, but they're also getting nice new things that have already been present on, let's say, 1155, such as UEFI, USB 3, SATA 6G, and specifically to X79 on the PCH, just like on 1155, we're introducing, we have the 2 SATA 6G ports, and then we have the 4 SATA 3 ports. So that allows them to step up to the latest generation in terms of SATA connectivity on boards.
Native SATA 6G on the enthusiast platform, which has not been available until now.
Yeah, correct. When you're talking about in comparison to X58, and on some of the other boards, we're extending the SATA connectivity even further than just the normal SATA 6. Excuse me, the 6 SATA ports that are present on the board. So we're definitely looking to push a little bit more depending on which board you go with.
So natively for X79, you get your 4 Serial ATA revision 2 3 gigabit ports. You also get the 2 Serial ATA revision 3 6 gigabit ports. So very similar to those of you who might be using Sandy Bridge right now.
Correct.
But also the additional features you mentioned, stepping up from X58 to X79. All right.
And I think as one of the last items before we kind of go into an overarching theme on what we have on our boards is the socket itself. 1155 had a very different socket than what we have here on the 2011 socket. So when looking at this platform, if you take a look at here, this Pro board that we have exposed, we can see here's the new CPU socket, and it's quite a bit more elaborate. You can see a lot more pins than the previous generation. But for the actual user, it's really nice because you're eliminating the use of any type of push pins. When we look actually here on our new heatsink, you see that you actually have a screw-based mounting system. So this is a great in comparison to previous generations where a lot of times either push pins were harder for people or you had back plates that you had to install. Now it's going to be very easy for the user. They can just go ahead and put this down onto the board, essentially like that. They screw it down. You have the spring retention screws in place so that you don't necessarily over-torque it. And then from there, it's just a question of inserting the CPU, which can be a little bit tricky. As you see, there will be 2 clips here that have to be lifted. These levers come out, and that's your CPU socket.
And if we might as well do a quick demonstration here. You were saying that it's best to actually lay this clip down.
Correct. You want to. The ideal placement would be to push that lever down, then insert the CPU. From there, you would then go ahead and pop it back out, put down the socket, close this one, and then close this one. And the main reason being is that if you try to insert the CPU into the socket prior to pushing this one down, this is going to be obstructing kind of your finger before you can place it in there, so it gets a little bit more tricky. So that is kind of the ideal kind of configuration in terms of setting it down.
Always best to lay the CPU in nice and flat with the LGA sockets. So nice little tip there for those of you guys going to 2011. Make sure that you don't bend your socket pins because that's always a sad day.
Yes.
All right, so we've discussed a lot of the just general features of Sandy Bridge E and X79, but I know ASUS likes to do a lot of little extra features, little details throughout their series of boards. So let's talk a little bit more about what ASUS has implemented across this entire series, whether you're talking about your channel boards, the Tough series, even the Rampage Extreme, or the Workstation board right over here. That's going to be similar throughout, but extra stuff that ASUS has done specifically.
Yeah, you nailed it on the head. I mean, always a big point for us is design consistency and kind of feature stacks that we feel that any user is going to appreciate across the board when they're adopting, like you said, any one of our segment series products. So we'll go ahead and we'll utilize, I guess, here as just as a base, our deluxe platform, just to kind of initially focus on some of these points here. So first and foremost, one of the biggest things that we've been advocating for a while now is a transition to digital power implementation. So this actually originally started all the way back on X58 with our Rampage 3 Extreme board. And it really kind of helped to push the envelope in terms of not only the granularity and control that was offered for VRM, but also to the extent that we could offer power delivery under higher level load configurations. So it really was about just trying to match the performance potential of the CPU with the best performance potential package in terms of power delivery. So we've continued to refine this, and this became our Digi Plus VRM design, which was very popular and really cemented in terms of its functionality and usability on socket 1155 with Sandy Bridge. And we're maintaining that now on X79. So we now have incorporated something new though. So we're calling it Dual Intelligent Processors 3. This incorporates a couple of different things. And you can see there, it's a logo there on the actual VRM heatsink. But we have our digital PWM. So the digital PWM is our digital power delivery for the actual CPU and for the actual CPU VRM. We're now extending it with our Digi Plus power control concept to Digi Plus DRAM. And Digi Plus DRAM is essentially a digital controller on the board, it's actually here, that will help to actually provide us advanced real-time level controls for the actual DRAM itself. And now what that allows us to do is we can fine-tune maybe better stability, better overclocking parameters, help to extend overcurrent parameters, a lot of different fine-tune elements. Just like we introduced with the digital power control, these options are going to be available to the users both within the operating system as well as within the UEFI. So we have full digital power control for both the CPU and for the DRAM, and that's on every single one of these boards. And we do feel that especially under the more complex configurations, 8-DIMM, higher frequencies, these type of controls will help to really be able to fine-tune and set up a system for the best level of stability as well as efficiency.
And memory overclocking in particular, especially when you're working with as many DIMMs as this, can be a bit finicky, especially the more density you get in there. So that's just going to allow you to really control the voltage at a very fine level.
Yeah, it's not only just the granularity in the voltage increments, but it's also even actually controls for specifically how the actual DRAM interact with the rest of the system. So such as the switching response time between the controller and the memory. And that's important to take consideration because we can do full real-time adjustments per banks. Because actually here, what a lot of users don't keep in mind is that DRAM can act very differently on this side of the board than it can on this side of the board. The main reason being, this is significantly more complex on this side of the board. There's a lot more traces laid out. There's a lot more potential interference for ESD, EMI, and a lot of other variables that come into play because of all this back I/O. So being able to fine-tune maybe driving strengths, switching frequencies, even different OCP levels, so current levels, all those parameters being defined can help you to normalize a more stable, high-level, high-density overclock with this type of Digi Plus power control. So we're really happy about offering this across the board.
Did you guys have any difficulty implementing all of this VRM, especially with the relatively smaller amount of room that you guys had to work with, just with the size of the 2011 socket as well as the quad channel memory?
You know, that actually brings up another really great point. Because of the efficiency of the digital VRM in producing less heat, also giving us more control at how to balance not only the actual phases, so the actual chokes, we weren't as restricted, but we did have to do some creative engineering. We're using a new type of more advanced choke that can provide more amperage, significantly more than our previous generation. We're also using a new dual N MOSFET package. It doesn't include a driver because the driver being included in a single package design would produce more heat. What we were looking for is maximum efficiency but also maximum performance. So this includes the high side and the low side MOSFET in one single package. So that allowed us to work within a much smaller space constraint, but we did have to do some special implementations such as put heat sinks here on the back of the board to help control temperature, especially at these higher level overclocks. So definitely working within a tighter constraint required us to do some efficient things, not only in the heatsink design, but in the package design for the units.
All right, and now as far as the X79 chip down here, as well as any other
yeah, there's definitely
hardware.
quite a bit more that we still have here as far as design consistent elements. So keeping here with that kind of dual intelligent processor themes, but going down to the bottom of the board, we have the TPU and the EPU switches. So we have an actual physical TPU chip and an EPU chip on the board. And what these help to do is extend the controls that are offered from the dual intelligent processor design in terms of the Digi Plus VRM and Digi Plus power control for the Digi Plus DRAM. So for the EPU, what this is essentially allowing the users to do is have a more efficient stock level experience, because it's going to provide less actually voltage to the CPU, so it'll produce a lower operating temperature and potentially help to extend the lifespan of the CPU. For the TPU chip, it's a quick and easy way to go ahead and enable an overclock on the system when you're first setting it up, not have to worry about anything at all when working with the platform. So you don't need to know, any parameters of, what type of CPU you're running, what type of memory configuration you're running. They can just flip the switch, and whether they're running the K part or the extreme part, they're going to get approximately about almost 4.3 gigahertz just from the flip of the switch. So a really nice, easy, and effective way to be able to extend overclocking performance.
And as far as all of these features that we're talking about, just to reiterate, the entire line, whether you're talking about the highest end Rampage 4 or the workstation board, all the way down to your more entry level here, the P9 X79, all by itself, across the board, all
across
of
the
these
board,
features.
all of them will feature it. The channel boards definitely will feature the EPU and TPU switches. For a board like the TUF, they might not be there, but those options will still be present via the TPU and EPU controllers, both within the UEFI or within the operating system, depending on the board. So you still have those options there. As we float over to the back of the board, if we go ahead and, here on the back I/O.
Inputs and outputs.
We're going to look at something that's very special and something that's unique to ASUS, just like our other designs, is we have this white USB port. This white USB port is something special. This is our USB BIOS flashback option. So for a lot of users, there's a lot of trepidation about flashing the BIOS on a motherboard. They're not necessarily sure how to do it, whether it's within the actual UEFI or within the operating system. So there can be a lot of confusion about how to get it done. So what we've done is provide a very easy method. The user just needs to take a flash drive, put the ROM file on the flash drive. From there, they plug it into this port, and then this button right here, they hold it down, and it will directly low-level flash the BIOS without any other interaction required. The really cool thing is when you're first setting up a system, to execute this USB BIOS flashback, there's no CPU, no memory, no graphics cards required. All the user needs to do is just connect the power supply here and for CPU power, and that's it. So just standby power is required. You can flash the board within about a matter of a minute and a half. Nothing else required. You don't have to worry about bending the pins to quickly put on the CPU, put on the heatsink, get all that set up. You're good to go. And from a recovery standpoint, you get flexibility in that maybe if the ROM were ever to become corrupted for different purposes, maybe a power outage, maybe an abnormality in a hard level overclock, something along those lines, you could also attempt to rewrite the actual BIOS ROM and update it through this USB BIOS flashback.
I've seen some other implementations of BIOS updating before. I've seen some boards have like dual BIOS, that sort of thing. But the ability to do that without even a CPU installed,
yeah,
that's a huge benefit, especially, for instance, if there's newer CPU revisions that come out that maybe you purchase this board in the future. You can always just plug it in right there and update, not to worry about compatibility.
It's the easiest way, essentially, at being able to always update the BIOS and not have to have any other components present, and just make it easier. Like you said, maybe 6 months from now, new CPU comes out, they have an older BIOS, they get that CPU, but the BIOS wouldn't post. They can still flash the actual UEFI, get it to that updated build, drop the CPU, and be good to go.
All right. And now speaking of our USB here, I notice you guys have quite a few USB 3.0 blue ports over here. And have you guys done anything special with the USB connectivity on these boards?
Definitely. I mean, USB 3 continues to be a big focus for us. Going even down to the standard board, we offer 4 USB 3 ports. But in terms of actually the functionality, we have extended it. through the combination of a new hardware controller, firmware, and a driver, we're implementing something that we're calling USB 3 Boost. When you're looking at USB inherently, the technology supports a number of different protocols in terms of how the actual information is transmitted across the bus. Your legacy original standard USB offered what's called bot transmission, which isn't very effective at very high speeds in terms of ensuring for like a USB 3 device. If you transfer through bot, you're not generally going to be able to achieve the peak performance of the USB 3 bus. It doesn't have multiple queuing support. It doesn't support multiple files being copied simultaneously, written or read. So there's a lot of limitations to that architecture. There's a secondary mode of operation that's referred to as SCSI. The SCSI protocol operation mode is significantly more advanced in terms of offering better performance, reduced CPU utilization, and some basic queuing support. Now, the newest standard that we're incorporating within this USB 3 Boost is called UASP. UASP is a new standard as part of the USB 3 specification group that supports significantly faster speeds for USB 3 when matched with a UASP compatible firmware controller externally. So, for example, if I take, for instance, here, this little USB 3 external hard drive that actually has an SSD inside, the actual USB 3 to serial ATA adapter within this has a firmware that supports UASP. So when I connect this to this USB 3 port, our actually AI Suite 2 software automatically transition this USB port to run into a UASP mode. This UASP mode will help to extend the performance of this device considerably. Take, for instance, this guy, which generally will peak out at maybe about 250 megabytes read and 250 megabytes write, which is still quite good. With UASP, we could extend that 100 megabytes on both the read and write performance. So it's a considerable increase to performance.
That's a pretty significant upgrade.
Yeah. The other cool part about it too is that it also can extend the performance for normal USB 2 and normal USB 3 devices. So even though UASP devices haven't necessarily hit the market yet, for anybody that's using any type of USB 3 device or any USB 2 device, they can shift from that bot operation mode into the SCSI operation mode, or as we term it, our turbo mode, and be able to also see an increase in performance. The range will, of course, vary depending on the type of device utilized. For some USB devices, it might only be maybe a 5 megabyte increase in read and write, but for a lot of those devices that maybe only have like 10 megabyte read and write, that's still a huge increase in terms of the performance. So it's something we're really about happy offering on our entire X79 range of boards here.
Excellent, and very nice feature there. And we also wanted to mention your fan headers that you have on the board here, because looking at all of these boards, and they all have 4-pin fan headers.
Yep.
And you were mentioning that you guys have improved your fan controller that's integrated into the board.
That's correct. We're actually using a brand new custom Super I/O controller that we phased in. And one of our big focus points is that spec isn't always necessarily comparative spec. When you look at one board, just because you see 4 fan headers, 5 headers, 6 fan headers, doesn't mean that you're going to have the same level of control and functionality that we're affording. So as part of our X79 platform group, all of these boards have the ability to have 5 full manual fan hand controllers be fully customized. So that means for, like, take for instance your push and pull CPU fan configuration for your back chassis, for your front chassis, and for your front chassis and maybe an optional fan, those can all be tweaked, tuned, configured. So we allow you to have the ability to have manual fan controls for each one of those. You can set them directly within the UEFI, or you can set them within the AI Suite 2 interface, or you can control things like maximum target temperature and the rotation associated with that temperature, as well as the lowest target temperature and the rotation speed set for that temperature as well. So really an extensive level of control that you offer on the entire lineup. It's quite impressive.
So you can set, say, a static RPMs that you want the fan to spin at, or you can have it based on the temperature that the fan is, that the case is currently running at.
Yeah, that's correct. Yeah, I mean, really the cool thing about it is just the flexibility. I mean, if you take, for instance, like a current generation chassis, which would work great for this board, like a Carbide from Corsair, you've got maybe like an H100 right here. You'd have a 120 millimeter fan, a 120 millimeter fan, another 120 here, another 120 here, and then a back 120, right? And so ideally, even with a placement, you can now custom configure all of those, right? Because maybe here you want to set specific target profiles for the CPU fan header in terms of it rotating when you put it under heavier load, but maybe you want to fix the hard drive cooling and also exhaust for the GPUs, maybe at a lower rotation rate because you don't need those to necessarily ramp as high as they would for the CPU, right? And maybe the exhaust you want to have to maybe the similar parameters or other variables. But the great thing is that it's up to you in terms of being able to tweak and tune that. We're giving you the ability to control those parameters.
Awesome. And yeah, plenty of fan headers. And you got them all at the 4 pins, so you have the PWM control.
And moving back over to the I/O here, one other really cool thing that we're still very committed to is Intel LAN. On our previous generation board, every board going up from the Pro included the Intel LAN controller. But we're really happy now is even going down to the standard board, which we have right over there, also includes the Intel LAN controller. And the big thing about that is, one, is it provides a higher level of performance. Two, it's going to give you superior compatibility and interoperability within different applications. And lastly is it has a very robust driver client. That driver client allows for a lot of diagnosis, packet adjustment, VPN protocol support, all kinds of different variables that are tweakable and tunable within that network controller. So outside of the performance-related benefits, there's also some very functional-based benefits for the enthusiast that wants to customize and tune the parameters relative to their network. So we're really happy about offering that across the entire lineup as well.
Awesome. So I think that wraps it up for what you wanted to talk about today. Am I wrong? Did we miss anything?
We've got one last item.
We missed one thing.
Yeah, you know us. We're always
so much information.
We're always willing to throw one more thing in there.
What is our final closing bit that we have to leave?
We have a diagnostic LED system that we're maintaining on all our boards, just because with these platforms having so many different variables relevant to the GPU, maybe to the memory, to the boot device, to the DRAM, we wanted to give users an easy way that they can make sure to troubleshoot the system.
Okay.
So on every single one of the boards, you will see what we call a QLED lighting system. So here, up by the Memo K button, we can see that we have one that says DRAM LED. And so that DRAM LED is just one of them. There's also one for the CPU. There's a CPU LED. There's a boot device LED. There's a graphics device LED. So maybe you don't have one of the modules fully seated. Maybe there's an initialization problem with one of the modules. Same thing maybe for the graphics card device. When there's an issue that's detected during the post-process with one of those items, that QLED can go ahead and light, it will lock, and then will allow you to visually, when you're first setting up your system, have an easy way to go, okay, there's an issue there, I can go ahead and make that adjustment, maybe reseat the module, swap it out, remove it, do whatever I need to do to go ahead and get the system to go ahead and post. But it's a much easier process than a lot of times when you're looking at a board that might have a debug LED. While the debug can offer a lot of code parameters and can be very informative, a lot of people don't necessarily know what all the codes really mean, and sometimes they don't want to go through the research process. So this is a much more visual method of being able to target the key points that generally impact the post-process. So that overall kind of gives you a lot of key symmetry points that we're offering on the initial 79 boards, and we definitely even have more relative to each board as we move up with the product stack, but those are definitely some consistent elements across the board.
All right, and you can stick around for a little bit and we'll talk specifically about each of these boards, and we'll follow up with some additional videos.
Yep, you got it.
That sounds great. All right, that's going to wrap it up for this video. Once again, this has been the ASUS lineup of X79 motherboards for Intel Sandy Bridge E socket 2011 processors. This is JJ with ASUS. JJ, thank you very much for sharing all this information with us. Thank you all for watching this video, and if you'd like to see more, please head over to our Newegg YouTube channel. Don't forget to subscribe. You can also check out JJ over on the ASUS ROG YouTube channel. Thanks a lot for watching, and we'll see you next time on Newegg TV.